So after this video, I'll go through the steps again. Last week we used the GitHub code spaces because in my default one, the dependencies are already installed. So I'll just go through it again and I will share with you the link. So today, what we are going to do, we are going to create a new project and then we are going to delve deeper into creating a more complex application. It's basically basic, but it's more complex than the default one. Because last time we covered, let's just create a new project. Maybe someone can suggest the name for today's project in the chat. File cabinet. Oh, that's a good one. Another one, something that uh, something ICP related and the ICP club related. A good name. Fusion. All right. Any other suggestion? Well, since there are no more suggestion, I'll decide to go with this, the one that Alex has posted, the Angokanayo. All right. So we are going to create a new project called Angokanayo. So just like last time, we'll use DFX new. Angokanayo. So since it's the first one, we'll start with Motoko, then we'll go into other languages. But for start, since Motoko was designed specifically for building on the internet computer, it has some advantages over other languages. So we'll start with the easier one, and then we'll go to the others. We'll go to Rust, and so on and so forth. So we're going to use, for now, actually, we'll focus mainly on Motoko, so the front-end part won't be an issue for now. So let's give it a few seconds to finish installing. So today's session, we are just going to take it from what we did last time. It's going to be a little bit technical, but not that technical. Just we're going to start with the basics about Motoko in just a simple way, in the way that I will do it. And then maybe we'll build a small internet computer app and deploy it and just take it from there. So it's still installing the node dependencies. Let's give it a few seconds. Well, today it seems to be taking its sweet time. I'm not sure why. All right, so it's done deploying. So I'm just going to show you the code base for the default one again and deploy. Then we'll go to deploying more advanced canisters. So after you've initialized your program, basically, what you're going to do is basically you're going to start DFX. And you'll start it normally with the clean and the background flag because you want to use the same terminal. So we'll just start again. We did this last time. DFX start, clean. All right, so after starting it, now we have to deploy our canister. For this demonstration, we're going to deploy it locally. So we'll just say dfx deploy. But in later sections, I'll show you exactly how deploy it to the on-chain to the mainnet. Oh, so just a brief recap again. After creating your project, you need to change your directory into that project first. So we deployed our project Angukanayo as Alex suggested in the chat. So we're going to change directory to that one. So after changing that one, you'll see that this is the project folder. You'll see the tsconfig.json, the node modules folder, the src folder. So let's now deploy it. Dfx deploy. Yeah, Alex, I've seen your comment just now. You're absolutely right. So I think it's a little bit slow because we are recording the session locally. We are running too many programs in the backend, in the background. But let's just be a little bit patient with it. All right, so our our initial project has deployed successfully. So I'm just going to show you exactly when you first deploy it, there's some default code that will be in it, basically just a greet function in the backend canister. And so let me just copy this one. So yeah, this will be basically our canister. We are accessing it using the candid UI. And you see in our canister, basically there's just one greet function. So let me open the code base to show you exactly what's happening. So I'll use VS Code. The VS Code seems to be updating automatically. So let's just give it a few seconds. So if you, in the meantime, as we continue, if you get stuck somewhere, just maybe send it in the chat. I'll be checking the chat periodically as we continue to see if there's any question. All right. All right. So this is basically the code base of our canister. And as you can see here in this SRC folder, the source folder, there are two folders, the Angukanayo backend and the Angukanayo frontend. So Motoko is the backend language, and we are going to see the main code base. And you'll see that in the code base, there's this actor, and there is inside the actor, there's this one function, this grid function, the one that I've highlighted. So as we continue, just a brief recap about Motoko. Motoko uses something called the actor model. And basically this actor model is basically a form of a computational model used for building decentralized systems. So and this basic actor, it signifies it's like basically the canister itself. So it starts this actor, you can call it, let's say actor hello, and inside the actor you input the functions that are going to be in the canister. And just before we continue, so this Motoko, it has some features that are basically tailored for building on a decentralized system. because you're not building like any other traditional system. You're building programs that are going to run on chain on the ICP blockchain in a decentralized system. That's why it's going to be. That's why we are starting here like actor hello, and then we are putting the functions in them. So one other feature about Motoko that you'll find that it has some features such as strong typing. The other feature is type inference, and the other feature is automatic memory management. And I'm going to describe exactly what that means in a few, but just if someone would like to tell us what strong typing is. What is strong typing? If someone would like to try and say in the chat before I give you the answer. All right. So just to describe what strong typing is, strong typing basically means that the type of variable it's known at compile. Hello. All right. Yeah, you can continue. The immutable data types is another meaning. Anyone else would like to try again? So, okay, so I'll just give the meaning now. I'll give the answer. So strong typing basically means that the type of variable is known at compile time. So I'll use I'll use an example. So a variable, let's describe a variable, let's say, let's call it Anguka, or let's call it X. So we are starting a variable X, and we are saying that it's an integer. And we're saying that this integer is equals to 5. So since Motoko this is just a warning because we have not used it, but this basically means that we cannot just decide to say that X is equals to, let's say, Hakuna Matata. We cannot just say that because this variable note that X is an integer. We cannot just and Hakuna Matata is a text. That's why we're seeing this error here. Literal of type text does not have the expected type. So you cannot do that in Motoko. In Motoko, once you say that a variable is an integer, that means that it's going to be an integer unless you explicitly tell it that you want it to be a text. So the other feature about Motoko is type inference. And this basically means, and I'll use an example again, type inference means that you don't really have to explicitly say that, let's say we are creating an X, which is an integer, a number. We don't really have to say that it's an integer. You can just say variable X is equals to 5, and Motoko will know definitely that that's an integer. So if anyone has a question while we are there before we continue, maybe you can just leave it in the chat. I want to go very slowly and make sure that you've understood every part because these basics will matter. All right. So we'll continue. I'm assuming everything is clearly understood until there. So the next part now, we talked about the type inference here. We can say that var x is equals to 5, and you can say something like a variable y is equals to, let's say, hello. Yeah, and that will work. When you compile, it will work. But though we are getting a warning because we have not used it. But we are going to use it in the future. It's just a warning, but it will compile. So the next part that we are going to talk about, let's talk about Motoko functions. So to describe a function in Motoko, basically you're going to use a func keyword, basically fu and c. So let's say, let's give an example of a function. Let's say a function that you want a function that can add something. You can say something that, let's delete this one first. Oh, even before it continues, you can see here, this one is a function. This one's a greet function, basically. And this greet, it's a function, it's a public query function. Public means that it's accessible publicly. And basically here return hello, as we'll go. This hash is basically a concatenation. And let me just create another function here. So let's say we want to create a function called, we want to describe a public function called, let's say, name. So here, when you'll describe the name, and before you continue, you'll say what function does this, what parameters does this function take in. As you can see in this greet function, it will say that it takes in a parameter called name. Let's rename it to full name. So here it takes one function called name, but here, so here we can give it the different parameters. Let's say you can ask it about, it can take in your first name and last name and say, my name is dash and dash and dash. So we can take it, the first parameter that it can take is first name. And we specify that this first name is going to be a text. Then it's going to take in your last name. And then this last name again is going to be a text. So after that, since Motoko function communicate you asynchronously, meaning that if a function wants to send a message to another function, it does not affect its computational process. It does not interrupt it. It's basically not, it's not blocking. So it's like you send a message, you say, I want this value, but it's asynchronously. It will say, it will tell you wait for it, and then you will the function will continue processing other functions. But when this other function is done processing, it will tell you, yes, I'm done, then you can continue. So that's why we're using the async keyword here. So it will return another text asynchronously, another text. And basically, so this, since our function is returning the full name, you can just say like, Motoko functions basically return the last function, but let's just use the return keyword again. I'll display the other part in the next sections. So here you'll say, let's say, so the function will return my name is, let's say your name is, and then a space. Then here we are going to concatenate. Concatenate basically means joining, and you're going to join the first variable, the first name, then we are going to concatenate, put there a space, then we'll concatenate the last name. So hopefully by the end of this, you'll basically understand what the greet function is when you see it. So we're going to use the concatenate, the pound sign, and the first variable that we're going to concatenate is basically first name. So after concatenating the first name, we're going to concatenate. Concatenate is just again a fancy term for joining. So we are going to join again. We're going to join a space. Then we'll concatenate the last name. So your name is, and it gives the name. So let's deploy our simple function and see the first one. So I'll show you about the shared keyword later, but basically when you add the shared keyword, it basically means that your function can be called from any other place. Let's say from outside, other function can call it. It can be called from any place, but we'll go deeper into it. For now, let's just stick with the basics. Just by the end of this function, you should just, when you see the query function, the greet function after deploying the default one, you should understand exactly what's there. That's basically the role of this first part. So again, you're just doing, I think we already started the effects again. We'll just the effects deploy. So let's give it a few seconds to finish deploying. So let's just open our backend canister again. All right. Yeah, so this is the function that we've written, the full name function. I've just reloaded this page again. So this full name function is basically takes in the first name, let's say Emmanuel, and the last name. And when you query it, it's going basically to return your name is. So that's basically what we've done. As you can see here in the code, basically returns your name is the first name concatenated with a space, concatenated with the last name. And just to reiterate again, concatenate is just a fancy word for saying join. So that's basically some basic feature about Motoko. So there are some steps that I skipped. So any question until you are there before we proceed, any question, you can just leave it in the chat. The first part is just to make sure you understand what the greet function is after deploying. Yeah, Caleb. Yeah, like in the first line, you see that this is basically the results that the function that we've run. This one comes by default. This is one that we've created just right now. It's just a public query function called full name, and it basically takes in the first name and the last name as the parameter. So take note of this, then look here, take a look here. So I'm trying to go very slowly so that you can understand. So here you'll see the first part, it's the first name, and the second part, the last name, and you basically call it. The candid UI helps us when we write a function, we can test it easily using its graphical user interface for testing. So basically you can just say, let's say your first name. So let me just call it first name. Let me just say first and last. Yeah, exactly. So whatever you put in as your first name and whatever you put in as your last name. And as you can see here, the first name, your name is, then you'll see here it says exactly that. Your name is, and then a comma, first name and the last name, because we put here first and last. Yeah, so the first name and the last name. So any other question before we continue? Let me check if there's another question. Yeah, it can be as complex as you want it to be, Caleb, but for now we are starting with just very basic examples, because even those complex programs are basically just built up of very simple examples, and when you combine very basic examples, they look very complex to someone else, but basically it's just simple lines of code and then the multiple simple lines of code. Or how I started the Candid UI. So basically, while deploying, when deploying locally, you are given these links. You saw, we after, let me just dfx stop it again. We wrote this command dfx deploy. Since, let me just, yeah, since we are in our project folder, we told it dfx deploy. And after dfx deploying, you see that you're given two links, basically the front-end canister and links for the backend canister. And since right now we are updating the backend canister, I'm giving you the simple basics about Motoko. That backend canister will come in, the candid UI will be there automatically. Let me just click again. Yeah, as you can see, I've opened it. Let me close it and open it again. When you're given this link in VS Code, basically click Control, then click. So you'll see here it's opening. When I go here, you'll see that it has opened. So this one, Candid UI, comes automatically when deploying. When deploying on the local, it's just already with DFX. All right. Any other question before we continue? If you are stuck, there's something that you did not understand, feel free to ask before we continue. All right. So I'm assuming you've all understood about the default functions. So let's just talk a little bit about the actor model just in general. Or let's create a new actor. This one is it came default, but you can create a new one just so that you can understand me better. So let's create a new actor called a counter actor. And basically we're talking about the actor is basically the canister. It signifies that this canister is starting from here to here. And we said again that the actor model is a computational model for concurrent and distributed systems, like different canisters, different actors. So let's start another one. We can call this one a, let's just something simple. Let's say it can count, we can give it a variable and it can add something like +1, just a simple function. So we can create an actor, and this actor we can call it counter, since it's just basically meant to count something. So, and in Motoko, it's just a good idea to finish everything to close it with a semicolon. Unless you don't want to add anything in the end, then you don't have to. So basically, we are creating an actor called counter. I'm just starting from scratch so that you can understand it. So on this actor, we can give it, it takes in a variable, let's say 1. We can call this variable x, and this variable x, we're basically initializing it, and it's 1. And again, this warning is just a warning because we have not used it, but not to worry, we are going to use it. And this counter, this actor called counter, we're going to add some functions in it, some basic function. The function can be something like increment or add one. We can call it whichever we want. So we'll call it this a public query function. And to create a function, you use the func keyword, and we can call this, let's say, increment, or in +1, it's just a random name. And so in this increment, this function is not taking any parameter, like unlike our previous function, it was taking in the first name and the last name. But this increment, we just wanted to add, let's say, to this variable x, we want to add it 1 or whichever number that we choose. So this one here is not taking any parameter currently, but it's going to return. We can decide, maybe let's create two functions. Let the first one just increment 1 to it and do nothing. Then you can create another function that will now increment, add 1 to it, and then tell us what has been. Oh, let's do it into one just to save time. So this function, it can return again. Which variable is it going to return? This one. Someone can try it and say in the chat. It's just based on the initial example. Someone can try. I want to know if you understood. Yeah, it's a good language, Washington. What's the return type of this variable here? Wait. Yeah, I saw Winnie said int. Yeah, you're absolutely right. It's going to return an integer. Yeah, so since we wanted to return an int, we are basically going to return asynchronously an int. Anyone who hasn't understood until where we are right now, before we proceed, how we came to an int? Anyone with that question? All right, since there's no question, I'm going to assume that everyone has understood everything. So this one is an asynchronous function, and it's going to return an integer. So basically what you're going to do, we're going to take this x, and what are we going to do to it? We're going to add 1. And so we can do this plus, there are two ways that we can do the short form or the long way. We can just say x is equals to x plus 1. This is the long way. And basically we say return x. Or the shorter way that we can do, basically to shorten this whole thing, we can just say x plus equals 1, and basically it's going to return an x. All right. So this was, let's try deploying it first before we continue. And then those who are really anxious about the complex part will get there. But basically, it's just going to be, once you understand the basics, you'll realize that there's nothing really complex in the end. So after it's finished deploying, I'm going to click on it. And so it's opening. So, and basically, as you can see, we've basically created a new actor, basically a new canister. We've created a new actor called counter with Motoko. And as you can see with Motoko, everything is very intuitive. So I've chosen to use integer. We can use the nut, but we'll have to import it. Since I want to keep everything very easy, we are just using the integer since it will just work by default. So this one's our new counter, our new actor called counter, and it's basically just one variable x, and we increment that variable x, we add +1 here, and we return the value now after increasing it. So basically, let me just show you what it does. You see that x was 1, we call it 2. When you call it again, it's going to come 3. Yeah, so on and so forth. All right, so any question while we are there before we continue? I think I'm trying to keep everything very easy. You can just leave it in the chat if you have any other question. Someone that you did not understand. All right. So I think by now you should understand what the grid function is, and when you look at it, you should understand what it does, and you should understand what basically an actor is, because the actor model is used for building for decentralized and concurrent system, and basically building a DAF for the Internet Computer Protocol blockchain, and the blockchain is decentralized. So I'm going to start now to this. We're going to back to the start now, like other programming languages. And in other languages, when you are starting, there's something that you will usually deploy first, and basically the famous hello world. So let's start there again. You can just clear this one here, and we can call our character now, it's hello, or we can choose not to give it a name now. It's okay, since it's just one actor right now. So what you want basically to do, like in any other function, in like, let's say if you've done any other programming languages, Python, C, PHP, all other Web2 languages, you'll always start with or JavaScript, you'll always start with the hello world kind of stuff. With the hello world, basically, just a program that tells you hello world. And that's what you're going to do. So in Motoko, we are going to write a simple program that will basically, when you run it, it says hello here in the terminal here. It's just basically for debugging. And so the first thing that you're going to do, we are going to import the debug module. So to import something new, let's say a module, you're going to import it like this in Motoko. You're going to write basically the keyword import, saying that you want to import something. Then we'll specify what name we'll use to refer to what you're importing. You can give it any name, but for a something short, we'll just call it D and say that we are importing it. We're importing it from the base module, so we'll say from the base class. So Motoko, and you say we're importing it from the base. And what are we importing? What module are we importing? We are importing the debug module. So we'll specify debug. All right. So we've imported it. Now we need to use it now. So to use it, we are just going to, like in any other language, what you're basically going to do, since while referring to this import module, we'll use D. So we'll just say D and say we're accessing which function from that module, and we'll say we want to access the print function. And basically, do we want it to print? Like any other language, you're going to start with the basic. Just say hello world. All right, and that's it. So let's run this simple program. So dfx deploy. So it's deploying. Yes. Oh, and just one thing, in ICP, when you are building your DApp in any, it's not going to be deployed in Motoko or in whichever language that you're using. In ICP, since it's a blockchain, it's going to take that Motoko code that you've done and it's going to convert it into something called WebAssembly. Then that WebAssembly is the one that is going to be pushed into the canister. So that's why, as you can see, it's taking some time to a few minutes deploy because it's converting it to WebAssembly. So let's open. It should be an empty one, but we should see here something called let's do this. Let's put it into a function so that we can call it, because I see it's not calling automatically. Yeah. So let's encapsulate it in a function, in whichever function, and we can call it whichever name that we want. We can call it, let's say, yeah, and again we use the func to name our functions, and you can call it, let's say, hello test, or whichever name you want. So this function is basically not taking any variable, and it's basically not returning anything, but we're just going to say, and to say it's not returning anything, and this hello world, we're going to put it in the function. And as you saw here, just one thing about Motoko. In Motoko, unlike other languages, after you're done writing a function, you'll need to close it with the semicolon, unless you don't want to do anything, because you'll see, if you put something here, you'll see an error here. So unless, if you want to prevent that error, you'll always need to close it. So even in functions, you need to close it with a semicolon. All right. So let's deploy it. GFX deploy. Just convert it to our module in to WebAssembly locally. So let's give it a few seconds. So ideally, when you run that using the debug, it should output the content in your terminal. But for some, oh, it was actually outputting in the terminal here, not in VS Code. I see what was happening here, and I was expecting it in the VS Code, but that's all right. So when you run it, you see here hello world, it output it in the Ubuntu. Since I'm on Windows, I'm using something called WSL, the Windows Subsystem for Linux. So let's reload this one again. So we are going to call it, and so now since we know it will not it will not display it here, because it's going to display it here in this terminal here. Yeah. Let me stop it here. All right, let me just deploy it using here because here it's deploying. The effects deploying. Oh. Or after stopping the effect, you'll need to start again, which you'll use the effect start. And here you say that you want to deploy it in the background since we want to use the same terminal. It's deploying now after a few minutes. No idea why. So let's now the effects deploy. So this is what we were expecting, but for some reason, it did not display it in time. Let's just try again here. But basically, this debug module is what you'll use while you want to test you want basically to debug your canister. You want to see the process that it's undertaking. Let's give it a few seconds. While it's deploying, let me see the chat if yeah, Joseph. Any other question while it's deploying? Today, everything is just taking its sweet time to deploy. Let's just be a little patient. So basically, just to reiterate again, just an actor, and we just want to do a simple hello world function, just like in any other language. That's the first thing that will deploy. If you're learning JavaScript, Python, you'll need to learn how to deploy the hello world before you continue. So while it's deploying, I'm not sure why it's taking time. But basically, we are just importing the debug module from the Motoko base library. And this is how you import it. You just say you're importing, and you say whichever module you're importing, you want to refer to it as whichever name that you'll put here. For us, we chose to just refer it as D for short. So we're importing the debug module from the Motoko base library, and we're referring to it as D. And then while referring to, we just say d.print hello world, because this print function is inside this debug module from the Motoko base library. Let me reload this page to see if, yeah, it finished deploying, but for some reason it did not display to us that it has finished deploying. But when you reload the page, you see that you're accessing it. All right, so we are just going to proceed. Let me try again. Yeah, I'm not really sure what's happening. But I think because I'm running multiple programs, I'm actually recording. In the next section, what I will do, I will I will use the Google Premium account to do the recording so that we can offset some of the processing power to it. All right, so basically, this is how you print a basic hello world. So what I'm going to talk about next, we're going to talk about basically the variables. And here, in our previous example that we used in the greet function and in the counter function, we you saw something called maybe var x. That's now there are two types of variables. There are mutable variables and immutable variables. And basically, this means that mutable variables can change, immutable variables cannot change. Before we continue, just if someone has a question. Career opportunities. There are many career opportunities. I think Tevin has mentioned majority if you're usually in the Wednesday sessions. And I know some friends of mine who have been hired to work in different ICP companies. But we'll create a session for that one. I think Tevin will help us organize with that one too. Yeah. All right. So let's proceed. I'm assuming everything is clear. Yeah. Yeah, I'll show you where you can start with this. For now, I'm just trying to teach you simply words, but I'll show you exactly how you can learn from scratch. And I'm trying to put everything as simple as possible, not to complicate anything, because you'll find that Motoko from the simple parts are just very simple. You just need to understand the simple basics part and combine it to create an complex dApp. But basically, just it's build up of very simple applications as you can see until here from the counter canister. This one is just for debugging. You won't really use it in your code. It's just for debugging. All right, so let's proceed. We are now in the variable section. Let's talk about the mutable variables. So mutable variables basically are variables that can be reassigned. Like we saw in the previous example, we created, so in the previous example, there's this variable called x. And this x, since we say one of the feature about Motoko, we said that it has something called type inferencing. We don't really have to specify that x is an integer. If you just say x is equals to 5, Motoko will know exactly that it's an integer. Since this one is var x, it's a mutable variable, we can reassign it. We can say, let's say that x, and to reassign a variable in Motoko, you'll use the colon. You'll say something colon. You'll say something like x is equals to 7. And as you can see, there's no error because that works in Motoko. So that one, it's a mutable variable. It can be reassigned. So there's another variable called immutable variables. And basically to create an immutable variable, you instead of using the keyword var, you use the keyword let. And as you can see, even as we just change before even we continue, you'll see that it will give you an error. You'll see expected mutable assignment target because you told Motoko that x should not change. It's a mutable variable. So when you want something that you know that you are not going to reassign it, and you want to make sure that you don't reassign it by mistake, you use the keyword let. If you want something that you're going to reassign, use the keyword var. So let is a immutable and var is a mutable, it can be changed. So any question until where we are right now? Let me check the chat if there's any question. So now that we are done with variables, all right, Joseph. So now that we're done with variables, the next section that we are going to talk about, we're going to talk about tuples. I think the best thing about, yeah, I think Dedan has left us given a resource in the comments, which you should check it out after this lesson. So I'm hoping I've kept everything very simple until where we are right now, because we're just going to do very simple stuff. You want to know even when we get to the complicated part. We're going to do just with the very basics and build basics and basics and basics, and then we'll combine them to form a complex dApp. But in the background, just the basics combined, right? So let's talk about another type called tuples. So, and to define a tuple, we can say, let's say, let tuple is equals to, and a tuple, you'll say, you'll use this parenthesis, and you can give it different values. Let's say the first one can be called hello, and the second can be called, let's say, like multiple ones. The next one you can call it, let's say, world. So that's a tuple there. And to display a tuple, let's say we want to use our debug module from the Motoko base library. We'll have to import it again. So, and as you remember in the other section, how do you import a module? We use the import keyword, and then we say we are importing. What are we going to call it as? We're importing the debug module. We'll call it as D. Then we are going to refer to it as again. So we are importing the debug module because we want to display our tuple again. And this one is nothing new. It's just what we did previously, and this is basically just another warning because we have not used it. Even here, it's just another warning because we have not used it. Now let's use this debug module and let's display our tuple. So display it again, we'll just use d.print, just like the other one. But now, as you saw in the other example, we were printing text. So if you want to print other variables, like let's say a tuple, you can't just say that you want to print, let's say, a tuple. That won't work. You'll have to convert it to a text, and to convert it to a text, you'll use something called, as even just code as suggested to us, debug show, and say that you want to display a tuple. And just as always, we need to always close our functions with a colon, a semicolon, I mean. All right, and that's it. Let's run it now. Let's give it a few seconds. Yes. All right. Let's now open it. We are opening it. It's empty there, which is expected because we'll see that there is no function here. But as you can see, we want it to basically just display our tuple. And as you can see here, this is exactly what it has done. It has displayed our tuple. All right. Any questions? Any question before we proceed? So that's basically a tuple, and then we've displayed it. Any question if you got confused anywhere? All right, since I've kept everything very simple, I'm assuming you've understood everything. So we are going to something just a little bit higher in the complex scale, but also very simple. And that's basically what we call arithmetic operations. And that's basically meaning plus, minus, multiplication, division, exponential. So yeah, so that's the next section that you're going to deal with. And you'll use this when, let's say, you want to create a DeFi application. When there's a change in balance or something, or when someone does something, you use the arithmetic operation to do. I think that's basically self-explanatory, the numerous uses of arithmetic operation. So first of all, I'll just tell you what the arithmetic operations are in Motoko. Then we'll use some simple examples and then continue to the next section. So the simple, let's call it arithmetic operators. So the first one, like we said, is the add, and it's just simple. In Motoko, add is just a simple plus. The next one is multiplication. So to multiply in Motoko, you just use a star. Yeah, that's basically multiplication. You do a star. You don't use an x, the normal one that you're used to. You use a star to multiply. And another one even before multiplication is the subtraction. I think if you've done other languages, you'll find that they are very similar to the other languages that you're used to do. Subtraction. So subtraction is just basically a normal minus. And division. So I'm just outputting to you the different arithmetic operators that you'll use. Then we'll use an example. And with the example, if you're new to this, you'll understand without a single doubt how everything works. So the next one is division. And division, basically, you just use a slash. And the next one is modulo, which is like the remainder of commonly known as modulo. And modulo, just like other languages, use the percent sign. Then the next one, and if you're confused, don't worry. With the example, you'll understand everything without a doubt. The next one is like the exponents. This one's a little complex, but or maybe you won't use it much, but it's good to know just about it. The exponent. So the exponent, it's basically you'll use the multiplication twice. That's the exponent. All right. Any question before we continue? Because in the next section, I'm going to show you an example of how you can apply the arithmetic operators. All right, since there's no question, let's use an example to so that you can fully understand it. So we've learned about variables. We've created different variables. Let's now create a variable and do some simple basic multiplications, division, subtraction, and then so we can create a variable, let's say x. And you can say in this x, let's use addition. We can say, let's say it's 10 plus 2. That's basically how to add. In the next one, let's say we want to use subtraction. I think that's pretty much self-explanatory. Let's just use something complex. Let's say we want to 10 multiplied by 2, and then let's add 5. What do you think is going to be the answer to this? Someone tell me in the chat. If we do this, what's going to be the answer? Just 10 multiplied by 2 plus 5. What's going to be the answer? Yeah, you're absolutely right. It's going to be 25. 52? 25? Yeah, it's going to be 25. So it's basically going to use the rules. I think you've all heard about board mass. It's going to do exactly that. Though if you want to change the order, what you can do basically, yeah, the answer is going to be 25. You're absolutely right. Here, if you want to change the order, you can change the order using parentheses. Let's create another variable. We can call it this variable. We can call it y. And we want to say that it's basically going to 10 multiplied by 2 plus 5. But we want to change now the order. So if you want to change the order, we are going to add parentheses like that. What's going to be the answer to this one now? I want someone else to try. The answer to this question here. The first one is 25, but to change the order, we can use the parentheses. Yep. Yeah, absolutely right, 70. All right. Yeah, the answer is going to be 70. Maybe you can just display it. So let's just show X just to prove that you are right and use it again. And so here basically what I'm doing is just like I showed you before. I'm just displaying it on the terminal after deploying. So we expect 25 and 70. Let's give it a few seconds. All right, so we are going to check here. Yeah, and it's basically, as you can see, at 25 and 70. Yep. So let's proceed now that this section is fully understood. Unless if someone has a question, I think we are going to go to the next section. Anyone with a question? All right, since everything is self-explanatory, and I'm doing my best to keep everything as simple as possible, even if you're just a beginner. So let's go to the next section. And the next section, you're going to talk about basically relational operators. That means if you want to check if something is greater than something, you want to check if it's lesser than. Let's say if you want to check someone wants to do a transaction on your DApp, and you want to check that they have enough balance in their wallet. You're going to use you'll say if the balance is less than this and this and this, then take this action. If not, then let's do this. So let's talk more about the relational operators. So here, the next section is going to be about, let me just clear this one. So let me add it here below it. Relational operators. Yeah, and relational operators, they are, let me start with the first one. Just if you want to check if something is equal to, you'll use a double equal, and this basically means equal to. The next one, if you want to check something that is not equal to, you'll just basically use not, and that exclamation mark is basically to negate, not equal to. So this one will be not equal. Again, just like the first one, I'm just going to describe the various operators, then we'll use an example which will basically explain what's happening. So the next one is not equal to, which is done. The next one is we want to check is less than and greater than. So just like other programming languages and what you learned in primary or high school, less than, just the same one that you're going to use. That one is less than. Then the next one, greater than. Greater than. So, and the last one that you're going to do, you can check something can be greater than or equal to. To you do that, you can just say let's, if it's less than or equal to, you can just use less than and combine it with the equal to. If you want greater than, you can just say greater than or equal to. So it will be greater than or equal to. Fantastic. So before we proceed, if you have a question, just leave it in the chat. I'm going to look at it before I do a simple example. All right, since there's no question, I'm assuming everything is crystal clear, clearly understood. All right, so let's do an example. Let's say you want to check someone, if their age is, let's say, greater than 18, they should, if greater than 18, 21, they should be allowed somewhere. If it's less than, they should not be allowed. So we'll create a new variable called age, and we'll, let's say their age is 21 years old. And we'll create another function called let, we can call it allowed. And we can say this allowed is going to be true or false. So we can say if age is greater than or equal to 18, then allowed is going to be true. So let's just again, let's show what allowed is. Though the next part we should, it will be very useful in if else statement, but we'll get there, so don't worry. So let's just for now display. I'll just copy paste this one for, and you want it to display what allowed. Let's give it a few seconds. All right, let's just open it, then we'll check. It's not going to display anything, but we're going to check here, and you'll see here it's true. So since we did not stop that, it's displaying the whole thing from top to bottom. It's displaying hello world, our variables here 25 and 70, and then it's displaying allowed. And basically, as you can see, let allowed is equals to if age is greater than 18, and you see that age is 21. So that means that age is greater than 18. So that's why allowed, here we see that the value here printed here, it's true. All right. I think in this, we are going now to the last part, basically the last part for today. And what we're basically going to do, we are going to apply the simple concept that we've done and just build a simple application that's going to apply all that we've learned today. If you have any question before we continue, for getting started with DFX, I'm going to create another video for the whole process. We did it live last time, installing all the dependencies. We used the GitHub code spaces. We showed you how to install everything from scratch. Let's say you've just installed Ubuntu. So Eugene, after this lesson, I'll record myself again and send it to the group. Don't worry. For now, just understand the simple concept that we are doing. All right. Is there any other question before we continue? If you have a question, just post it in the chat. All right. Since there's no any question, we're going to create just one very simple application that's going to combine what we've learned today. All right. So today we've learned about the actor. So let's close that one up. So the simple application that I think we should create, something that can show the arithmetic operations, the greater than, less than. Let's create a simple canister on the ICP blockchain and call it a day. So the simple canister is going to be, we can call it just again, we use the actor keyword and you can call it calculator. So this simple actor model, like we told you, since ICP, you're building applications that are going to be hosted on the blockchain, and ICP uses the actor model, which is a model used for concurrent and distributed systems. So that's what we've initialized another actor called calculator. You can choose to call it nothing. So the first thing that you're going to do, we are going to create a variable called the DAP name, but it's not really needed, but just to apply what we learned about variables, and we are going to call it, let's call it ICP calculate. All right. Right, since so I think let's display it just to apply the using the debug module from the Motoko based library. So let me write it and see if it's going to be automatically suggested. D.print. Yeah, since it's not, we'll have to add it manually. So again, we are going to use the import keywords, and we are going to specify what we'll be referring to it as. So we'll refer to it as import. You can call it whichever name we want. If you want F, you want, whichever one you want to call it, debug, whichever you want, but for now we're just calling it D because it's very short. So we're going to import D, and we specify here that it's going from the Motoko base library, and from the Motoko base library what we're importing is the debug module. So just say debug, and by the not the capital D, don't forget about that one. And as always, we close our statements with the semicolon. And since this one's a text, we'll just say that now. Fantastic. Okay, let's proceed. Now our calculator will need to have some functions. So if you have any question, just leave it in the chat. I'll be checking the chat periodically. But for now, this is exactly what I've just shown you previously. It's nothing complex. Just so we are going now to give our calculator some functions. Our calculator should be able to add, should be able to subtract, it should be able to do simple multiplication and simple subtraction and division. So let's create our function, our first application, which I think, yeah, let's create the add function. Since it's going to be the simplest one to create. So again, to create a function with the keyword func, F-U-N-C. So public, and we're going to call it, since it's going to a function to add, we're going to call it add. And this function, just like the greet function, it's going to take in two parameters. So the first parameter, we'll call it a, and basically it's going to be an integer. And then this integer, we're going to add it to the second one. Basically, we're going to call it b. And this is going to return an integer. And don't forget about the async keyword. Going to return an integer. All right. So now that's taken care of, now we are going to write what's going to be in our function. And basically, we can just do a plus b. Actually, that's okay since we're in Motoko. It will return the last function, but if you can just use the return statement, but because it's the last one, you don't really have to. In the division function, I will show you section whereby we use the return and where we don't use the return. So any question while we are there? All right, since there's no question, you're going to create now the subtract function. Add function. The next one is going to be the sub. If you have any question, again, just leave it in the chat. I'm going very slowly and making everything as simple as possible so that you can understand the basics. So the next one is going to be the subtract function. And the subtract function is going to be very, very similar to the add function, except what we're doing is now subtracting a minus b. So again, we'll just use subtract. And again, it takes in two parameters. The first is an integer. The next one, b. Going to return an integer. Basically just a minus b. And like we said before, when in Motoko, you need to remember to close everything with a semicolon unless it's the last statement. You see here, this one's an error because we did not add here a semicolon. If you're going to add more function, even if it's a function, in other programming languages, you can just keep the semicolon after creating a function. But in Motoko, you have to close that function with a semicolon. So it's going to automatically return the last statement. So we don't really need to use the return statement. So again, if you have another question, just leave it in the chat. I will periodically take a look at it before we continue. So the next question that we are going to do is simple multiplication. All right. Actually, multiplication is just going to be as simple as this one. To save time, I'll just go to something that's a little bit more complex. We'll create the debug function. I mean the divide function. So we're going to create, this one's a little bit more complex because in this one, you're going to check that you're not dividing by 0 before you proceed. So it's just a little bit different. But for the multiplication, again, you just create public function and you name here, you name the function, this is the function name. So name here multiplication and just change the sign to a multiplication sign. Like we showed you in the previous, basically just a star. So here we'll go to the division, public func, and you can call it divide. And this divide again is going to check two parameters because we want to divide A divided by B. And you're going to check to make sure that B is not 0. So again, this one's an integer. Again, B. This is just a very, very basic calculator. Just meant for you to understand all the concept. Again, you're going to use the async keyword. Yeah, we can make it more complex in later stages, but for now, let's just keep everything simple. So here we are going to check to make sure, before we continue, we're going to check to make sure that B is not 0 because you cannot divide a number by 0. So what we're going to do, let's add this one here because it might return the answer for the division, or it might not. Let's say if someone gave the number B as 0, you'll say that will return something like null, something empty. All right, so here we'll use the if function. Again, I'll describe this. So we are going to check if, and like I told you, the conditional operators, if B is equals to 0. What do you do if B is equals to 0? You cannot do the division sign now. What we'll just say will return, let's return null. So else, here to remember to use the curly braces. These ones are curly braces here. So else, if B is not equal to 0, now we can do now the multiplication step. So we'll just do, in short, we're going to return and join them, A divided by B. All right, that's basically our divide function. So if you have a question there before you continue, this is a little bit more complex, but just simple nonetheless. If you have a question there before we proceed, I want to make sure that you've understood all the simple concepts. All right, so I'm assuming everyone has understood that. All right, now let's test our function now. And just one thing before you continue, if after you've installed WSL or you have VS Code in Ubuntu, make sure that you've installed this extension called the VS Code, the Motoko extension. Where is it? Oh, here it is. The Motoko extension. This Motoko extension is going to be useful if you have an error in your code. It's going to tell you. So basically, you'll just search Motoko and you'll find it. Just a simple tip. You'll find the one for Dfinity Foundation. In the first class, I talked to you about Dfinity, and I told you that they are the major contributor to the ICP blockchain. So that's the main one, the Dfinity Foundation. So you'll add that Motoko. When you write an error in your code, it will just tell you even before you get to the deployment phase. All right. Now let's deploy our simple canister, our simple calculator. Right, let's give it a few seconds to deploy. Oh, that's a very good question. So the question mark is telling it's basically communicating that it can return either an integer or nothing. Because we are adding this one because what if b is 0? What if someone says that they want to divide by 0? So if you can't literally divide by 0, so in that statement we are returning the null. So we're just adding the question mark to be on the safe side, to say that will either return a value or it will be empty. It will be a null. Let's close this one first. Let's reload our page now. Fantastic. Now, as you can see in the candid UI that we've done, let's just again, you can see here we created the add function, the subtract function, and the divide function. The multiplication one we skip because it's just a derivative of these two. Basically just saying public function multiply and saying a and using the star here. So, and as you can see the divide option, you see this one, the next one is an optional int. Giving the option it might be an integer or it might not. So you use the question mark saying that here it might be an integer or it might not be an integer. And so here basically you've done you can add, if you add let's say 2 plus 2, you'll get what? 4. And so it's going to add 2 plus 2, just like in our function here. It adds just 2 plus 2. And like I said, Motoko, the function will return the last statement. So you don't really need to use the return keyword, but you can use it if you want. It will return. If you, let's say you are ending before the final one, you can now use the return like here, because it's not the last statement. But here, you don't really have to use the return keyword. So that's the add function, and the subtract function basically subtracting a minus b, taking the parameters a, b. Again, let's test that one. So the subtract function, let's say 10 minus 5, just I'm using something very simple. And we should get the answer 5. Yep. If we say minus 4, we should get 6 here. So I think that's self-explanatory until there. We are going now to just display our final one, the divide function. And I can see our time is almost up. So divide, let's say 10. If you put 0, it will basically, you can't divide by 0. That's why we're using the, yeah, it's returning the null operator here. That's why we are using here the optional operator here, saying that it might return an integer or it might not. As you can see, if b is equals to 0, it will return null. This other one is just to be on the safe side, but basically the same concept. If no value is there, it will return an empty one. So 10 divided by 2. Yep, it's going to return 5. And as I said, the question mark is just an optional operator. But since we are already checking here, we don't really need it, but just something so that you can understand how it does. If you think maybe something won't return a value, you can use the question mark, something that will return a null. So it will return either an integer or it will not return it. All right, so that's basically it from there. I think in the next section, I think I'll start by showing you, our time is almost up, and I'd like to end it from there unless someone has a question. But in the next section, I will show you how to create a GitHub repository and to deploy whatever you've done, because whatever test that you'll be doing after, while you're going through this video again, you need to deploy to a GitHub repository before sharing the link in the ICP Club's canister. So should I show you right now or in the next section? Maybe someone can tell me your opinion in the comments. I can either show you how to set up the GitHub right now or in the next section. All right. Since there is no other option, next section. Right. So in the next section, I will show you how to deploy your project in the GitHub, because when, let's say, you are encountering an error and you need some help, you can't DM me on WhatsApp the code. You'll need to upload it to the GitHub, or let's say you are collaborating with someone else, you'll need to push it to GitHub. Okay, my hope is that today that I've made the session very basic, very simple, because Motoko, actually, if you go to the basics, it's very simple. And awesome. Thank you. So if someone has a question, I will end today's session from there. The floor is open to someone who has a question or someone has something to say. You can just unmute your mic and speak. Okay, I'll stop the presentation there. And just after you're done deploying, to stop it, you'll just use the effect stop. Just here, the effect stop. And that's it basically. So I'm just going to stop there. All right, Eugene, I will create that one from scratch and send it in the WhatsApp group. How to do the effect dependencies, everything from scratch. All right, any other question? Awesome. All right. Okay, now that everyone has understood everything, Laura, do you have anything to say before we close the session? All right. Awesome. Okay, we're going to end this section here, and hopefully, based on the feedback, I'm assuming you've understood everything. I've kept everything very simple and they're just the very basics, because that's basically Motoko. Just simple basics combined. Many basics form a complex DApp, but it's just basically the basics, the addition, subtraction here and there. All right, thank you, Kevin. Okay, without further ado, since no one, all right, I will I will upload the video to YouTube and then share with you the link. All right. Okay, so I'm going to end the call here. Thank you for attending the session, and I hope you learned something new today. I hope everything was just as simple as it is, because Motoko is very simple. The basics are very simple to understand, and I hope that you experience. So have a fantastic night. Good night and thank you.